Howdy folks. This is going to be a part 2 of the auth stuff that I put up yesterday, covering a couple other concepts and things I didn't manage to get to. The first thing that I want to talk about is when we're actually creating a user, we would like to encrypt their token. So you might remember that the last time we went over this, I'm storing these passwords unencrypted, which is really bad for security. So let's just take a look at that again, just as a reminder. So you can see here, this password is in plain text, which is definitely not ideal, definitely not what we want to do. Because if someone manages to hack this database, they'll just automatically have the password, and we don't really want that. So there is actually a way in Sequelize to make sure that we do our encryption. Well, first of all, maybe I'll just show you how to do the encryption. So let's actually create a route for creating a user, because we inserted this data manually, but now it'd be good to have a route to actually create the user ourselves, because we're going to need to do that. User router dot post slash. So this is different from post login. User router is already hooked up to slash user. So if we post to slash user, that says we're creating a brand new user as opposed to login. There's some debate as to whether login would actually belong here, but I think it is because it's a user action. Async class. All right. And so then we're actually going to grab the same body out of it. If you had like anything else like name or email or stuff like that, this would be the time, but my database, let's just take a quick look at that, only has username and password, so we're not adding any of those other fields. All right, so first of all, I want to actually do this same check for username. Why? Because I want unique usernames. I don't want someone creating the same username twice. So in this case, I'm going to say if I found a user, then am I going to actually send a 409 status. What is 409? It stands for resource conflict. And it's very commonly used in this case where you tried to create something that already exists. And then end user already exists. All right. So what if that user doesn't exist? Well, then we're going to create it. User equals await user.create. And then we pass in our values, password like that. Then we're going to return res.whoops, we're not going to return status 200.return, not return again, JSON ID, new user.id, just so that the user knows what their new ID is. So if I do this, oops, username, this is still not going to encrypt the password, but let's just make sure that it works. Let's get Postman up. All right, so if our login, we have our get user. We're going to make a new request. It's going to be a post request, and I'm going to call it create user. We're going to save it here. Localhost 3001 user. We're going to give it our content type, application JSON, because that's what our system knows how to accept. And username test2 change me. So let's start up our server. And all right, we're using NodeMon, so that should bring it up. And then let's run this. Okay, we get ID 2 with a 200 OK. Cool. If we try to run it again, we get a 409, and it says user with username already exists. Good. So now let's take a look at that SQL again. Password is still not encrypted. So how do we encrypt our password here? Well, we want to use a module called bcrypt. And bcrypt, let's just see, because I don't remember if this comes standard with Node or we need to install it. Bcrypt. So then what we're going to do here is we're going to say, okay, encrypted password equals bcrypt dot hash, and then we give it the password, and then how many times we want to run the encryption. You want to do more than once because one encryption can still leave data that is close enough to existing data that you started off with, but 10 times is going to make it completely unrecognizable. So I pass encrypted password in here. Module not found. Okay, so there is no bcrypt module. Cool. I mean, there's no default bcrypt module with Node, so we have to install it. So it's install bcrypt. All right, there we go. That restarts. And now if I go through with test 3, oh, no, we got an error. Oh, got to spell it right. That would make sense. See, the nice thing about NodeMon, as soon as I fix the bug, it restarts the server. Cannot get response again. Another error. Not a string. Password cannot be an array or an object. Oh, I think because this actually returns a promise. Bcrypt hash, I think, returns a promise. So let's try that again. There we go. So now we have ID 3, and now let's check that user. And now you can see that is an encrypted password. That password is change me, just like the previous one, but it is definitely encrypted. Well, now here's the problem. Let's say I want to log in as that user. Okay, so I go user 3, change me. Let's just make sure that test 3 and change me. Okay. And I go to log in. It says there's a bad login. Well, why does it say there's a bad login? Well, because our check is just checking to see that the passwords are equal. This is obviously not equal to change me. And that's kind of the point. We don't want it to be. So then when I'm entering data from my API, the user doesn't know this string. This is to ours. The user knows this is the password they put in. How do we verify that? Well, as it turns out, there is actually another bcrypt thing for that. So what we're going to say is equals bcrypt dot compare sync, because we want to do it synchronously, login password, which is going to be our password, and then the encrypted string, which is going to be user.password. And then I can just say if password valid. Okay, so now I go here and I change this to some invalid string. It gives me bad login. I give the correct string. It gives me my token, my session token. So now our API is 1,000 times more secure because, or our system rather, not our API, because our passwords are now encrypted. This is powerful encryption. What this means is if someone steals my database, which could happen, they don't have the ability to decode this. I don't have the ability to decode this. This is a one-way encryption. So how does it work then? How are we doing this comparison? Well, what happens is when the user enters their password and I do this comparison, what it essentially does is it re-encrypts this password and then verifies that it matches, which means that if I put in the wrong password, the hash is not going to match, and it's not going to match in such a way that it doesn't even tell me how close it was. It doesn't necessarily even tell me if I got half of it right, which is really what we want, because we want, if someone's attacking, we don't want to give them any clues about, oh, you got the last 10 characters of the password right, you just need the other 5. We don't want that. And so the bcrypt module here, the way it's encrypting prevents us from getting that data, because this hash, the only way to validate this is to re-encrypt another password and just compare the two strings. So that's part 1, figuring out how to get that. The other thing is, notice we did this here. We just encrypted the password and did this user create. Well, what if someone's creating users somewhere else and they forget to encrypt this password? that would be bad, not only because there's an unencrypted password in the database, but also the login won't work anymore. Because if I try to log in as test2 now, even with the right password, it won't work because bcrypt is expecting this value to be encrypted, and here it's not, so which means we always need this to be encrypted. So Sequelize can help. When we go in here, in our options, so this is the model. In our options, we can have hooks. And there are a couple of hooks that we can use. One is before create. Okay. And we're going to call it new user data. So what is a hook? In Sequelize, this hook, or this function, is called right before I create. So let me show you. So now if I go to insert another user, let's go create user 3 or 4. And I send this, creates user 4. But you can see before create called with these data values. The ID doesn't exist yet because this happens before the user is actually inserted in the database. You can see down here now that insertion happens. So at this point, if I manipulate any of these values, that is what actually gets inserted. So that means what I can do is I'm actually going to take this bcrypt, pop it in here, and I'm going to encrypt the password inside of the Sequelize. So right here, I'm going to say this, and I'm going to say, okay, new user data dot password equals hash new user data dot password. And what is this going to do? Well, this is going to, every time I create a user, it's going to encrypt that password field, which means I don't actually need to do this anymore. I can just pass the password in unencrypted here. All right, so now let's try that. Let's go with test 5, okay? And if I go to MySQL, you can see test 5 still has the encrypted password. Even though I didn't encrypt it here, because this function gets called automatically every time a user is created and magically encrypts the password. So that's pretty useful in this case, because it means that no matter where someone creates a user from inside our system, as long as they do it through the Sequelize model, that password is going to be appropriately hashed. Which we want, because it's possible that, like, maybe I accidentally forgot and I put this code somewhere else and forgot to hash this password in it. That'd be bad. So unifying it in this one spot just makes it easier to avoid those kind of bugs. So that's how you can use Sequelize to help you keep these passwords. So the next thing is we're using cookies right now. And cookies are fine. I want to talk about how we would use this as a bearer token, though. So there's two kinds of authorization. There's cookies. So you can see we have this get user and we use this cookie. There's another type, which is not cookie based. It is an authorization token or an authorization header. So for that, you use the authorization header here. Actually, let's make a new. Let's just make a new request that's that uses this. Just call it me too because I have no ability to have an imagination. So let's put authorization here. An authorization, you give it a type. The most common type is a bearer. And bearer just says this is a bearer token. This token bears the ability, or it is the bearer of the authorization. So to do that, I would say bearer, and then I would pass my in like this. So this is a pretty common way of calling third-party APIs. You don't do this as often if you have an API that's meant to be called by a client. So like the original get user that we have, this is meant to be called by a client, which means it's using cookies. This one is meant to be called by as like a third-party API, which means that we're using an authorization header. If you don't really understand the difference, don't worry about it too much. But hopefully, if you're curious of like other ways of doing authentication, this is how we do it. So what we would do then, let's create that. Me too. In this case, we're not getting the session token from the cookies. We're getting it from the headers. Headers like that. Let's just console log authorization. And I'm just going to end at this point. Just because I want to verify that this works. All right. So I'm going to go and I'm going to send this. Okay. Oh, it's undefined. Okay. So the way that we actually do this is we use the get method. It's not an array. Which, good to know. Auth header and then auth header. Okay, so let's go ahead and run that now. Response. Oh, what did it crash on? Oh, misspelling. You gotta spell things. All right, so there we go. So now here's our token, our bearer token, which it's a string. So not the most useful thing. So let's split it. Type session token equals auth header dot split. If we split by a space, you can see that this will become the first part, this will become the second. If type is not equal bearer, this is something you usually want to build a middleware for. Express might also have some existing middleware to handle this. I'm not familiar with them if they are. Res dot status 403 dot end token type must be bearer. There are other types of authorization headers, and so we're only looking for a certain one. But in this case, now we should be able to continue forward because the session token's been broken out. We can verify it with JWT just like normal. So we run that. Oh, it gives me bad login. Let's see. Bad login 403. That's interesting. Let's console log the error. See what happens. It might be I may have copied the token incorrectly. The error is token expired. Ah, that's pretty cool. So you remember when we created these tokens, we created them to be 2-hour tokens, and so that token has now expired. So let's actually go to our login here, and let's log in as test3, and let's just grab this this token again. Come here. There we go. Get user. I'm gonna. Oh, I didn't save this. Oh, here it is. And let's pass this in as the new token. And there we go. Now it works. So that's how you would handle this if you're using the authorization header. Is you get the header, verify the type, and then you can verify the token just like normal. So you can see it's not super different. It's just the cookie gets handled automatically. Save this as get user 2. And this is more commonly used if you're calling a third-party API because it's just easier to set an authorization header than it is to set a cookie. Sometimes you will actually do this for client stuff as well, but that's a little less common. Next time, or next video, I'm going to show you how to integrate handlebars with this because there's a little bit of complexity in how that works. But I think this is enough for now, just going over these two concepts. I hope this is helpful, and I'll see you all in class.